In this video, we developed the derivative formula for cosine of x. We'll need the same background information that we needed for sine of x. We'll need the trig angle addition and angle subtraction formulas from trigonometry, and we'll need these limits that we needed again. Basically, the trig identity that we'll need is the one for cosine of angle addition, and we'll need the limit as h approaches 0 of sine of h over h equals 1, and the limit as h approaches 0 of cosine of h minus 1 over h is equal to 0. Okay, with those in mind, let's develop the derivative formula for cosine of x. According to the definition, this is the limit as h approaches 0 of cosine, where each instance of x has been replaced by x plus h, cosine of x plus h, minus cosine of x. Notice this is the change in the function value of cosine, or like the delta y, divided by h, which is the delta x, and we take the limit of that as h approaches 0. Using the angle addition formula for cosine, this is, of course, the limit as h approaches 0 of, well, cosine of x plus h, using the angle addition formula where alpha is x and beta is h, is going to be cosine of x times cosine of h minus sine of x times sine of h, and all of this is the cosine of x plus h, and then we need to subtract cosine of x. And everybody gets divided by h. Now notice, if we would look here, there are two terms in the numerator that contain a factor of cosine of x. I will group those together and take out the factor of cosine of x, and this would become the limit as h approaches 0 of cosine of x, common factor that is removed, I'll say over 1, times cosine of h, and back here we'd have minus 1 all over h, minus, and then notice there's a factor of sine of x that I can take out, and I could write this as sine of x over 1 times sine of h over h. And taking the limit of the difference is the difference of the limits, and the limit of the product is the product of the limits. This becomes the limit, or this is, I should say, the limit as h approaches 0 of cosine of x times the limit as h approaches 0 of cosine of h minus 1 over h minus the limit as h approaches 0 of sine of x, times the limit as h approaches 0 of sine of h divided by h. And of course, cosine does not depend at all on h, so the limit as h approaches 0 of cosine of x is simply cosine of x. From above, the limit as h approaches 0 of cosine of h minus 1 over h is 0. And by the same token, the limit as h approaches 0 of sine of h is sine of x. And provided we are expressing our angles in radians, the limit as h approaches 0 of sine of h over h is equal to 1. So notice this becomes 0 minus sine of x, or negative sine of x. So therefore we have our derivative formula, the derivative with respect to x of cosine of x is equal to negative sine of x.